So we've been solving systems of linear equations, and we've been using a strategy that we call elimination, where we line the two equations up in standard form and we look for a column that has opposites and we add them straight down. Well, in this particular system, you'll notice that we don't quite have opposites. The first column shows a negative 5 in both places, right? Negative 5x and negative 5x. So when we add straight down, those won't cancel. They'll make negative 10. This is where I like to play the wouldn't it be nice game. And I say to myself, man, wouldn't it be nice if this was a positive 5x right there. Well, as you know, I'm not just allowed to change one term in the equation. But if I'm consistent and do the same thing to all the terms, we'll be okay. You can look at this two ways. You can think of this as I'm going to multiply by negative 1 to every term on the bottom. And what that does is it changes the sign. So the negative 5x becomes plus 5x. The plus 3y becomes plus negative 3y, and the equals 19 becomes equals negative 19. So you can think of it as we multiply by negative 1. You can also think of it as we want to add the opposite, right? Rather than subtracting these two equations, which is what we would need to do to get a 0 and to eliminate the 5x's, what we're going to do is add the opposite. So subtraction is what we want to do, but we add the opposite. You can think of it that way also. The bottom line is we've been saying we keep flip change every term in the bottom equation. So now we've created opposites, and now we can go ahead and run that elimination method. The elimination method is simply to add straight down. We're going to combine these equations and eliminate one of the variables along the way. So we do negative 5x plus 5x, and that eliminates. We do 7y plus negative 3y, and that'll give us a 4y. And we do negative 19 plus 11, and that'll give us negative 8. So we have a new equation, 4y equals negative 8. That's pretty easy to solve. We're going to divide by 4 on both sides. And lo and behold, we end up with y equals negative 2. So we're halfway to the solution, right? We have the y coordinate. We still need the x coordinate. Our strategy for finding the x coordinate is to take this y equals negative 2, to take that negative 2 value and plug it into one of the equations. We usually pick the one that has the fewest negative signs because that's we like to do math with positive numbers. So I'm going to pick this top equation, the original top equation, which was negative 5x plus 7y equals 11, and we'll see what happens. So I just write the equation out again, negative 5x plus 7y, but when I get to the point where I want to write y, I'm going to substitute this negative 2 in for y. And then I finish it off with equals 11. Now we know this is actually negative 14. So basically this is negative 5x minus 14 equals 11. That's the equation we're going to solve. You can see I've run out of space here, so I'm going to start a clean slide and we'll finish this solution off. We've used elimination to solve for y, and we've plugged in negative 2, and now we're at the point where we need to solve this equation. Negative 5x minus 14 equals 11. We're going to use inverse operations. We're going to do plus 14 to both sides. That eliminates the 14. I end up with negative 5x equals 25. That's great news. I know how to solve that. Inverse operation will divide by negative 5. And we end up with x equals negative 5. We put this together with the y that we found earlier, and we have our solution. The solution is x, negative 5, comma y, which was negative 2. And we're in business. We've solved the system. Right? This is the ordered pair where the two lines cross if you were to graph them. Good luck with elimination, and have a good day.